Today we're going to demonstrate how MapMasq can help state, county, and local governments share location-enabled health data while protecting privacy. So let's get started. Many state, county, and city governments have access to protected health information. This information, if made available to others, could give valuable insights through location analytics and visualization. Many organizations already have access to ArcGIS Online or ArcGIS Portal, which is a platform for the sharing and collaboration of location information. This existing infrastructure would allow you to share information with public safety, emergency responders, healthcare providers, and even among state, county, and local government departments. However, the privacy requirements of the Health Insurance Portability and Accountability Act, or HIPAA, rightly prevent open disclosure of information. Additionally, ArcGIS Online is not a HIPAA-compliant environment. In order to share the information, it must first be de-identified so that it can be put into a non-HIPAA compliant environment. This is where MapMasq can help. By first using MapMasq to mask the data, de-identified representative data sets can be created that are no longer PHI and can be stored and shared outside a HIPAA-compliant environment. MapMasq aims to de-identify data to protect privacy while minimizing the loss of the analytical value of the data. So what does MapMasq actually do? It takes discrete data points and masks the spatial locations. It does this by randomly distorting data while attempting to preserve the spatial patterns. It will support aggregation into bins, and it will support aggregation into the bins based on census populations also. I do want to stress though that MapMasq is a calculator. It is not an easy button to HIPAA compliance. MapMasq uses the expert judgment rule within the HIPAA regulations. Depending on your data set, location, sensitivity, and your HIPAA compliance auditor, you may or may not need to apply additional or other methods. Links to published studies on these methods can be found at mapmasq.com in the resources section. First, let's look at triangle, square, and hexagon bins. Using these bins, you can clump data or cluster data without distorting the data too much and be able to aggregate it at a much smaller level. On the left, you will see some point data, which is your protected health information. The toolbar you see is the easy-to-use MapMasq interface, which we will demonstrate shortly. In this case, the user can pick from triangle, square, and hexagon bins, and adjust the size of the bins based on the extent or sensitivity of the data. This allows the user to customize the bin size to meet the HIPAA requirements established by their organization. On the right, you can see what a 2 square mile hexagon bin looks like on the city of Austin. Next, let's look at what some call the numerator rule. Using census geometries to determine the boundaries, the numerator rule simply states that for a release of information, you're required to have at least a certain number of events or occurrences per geometry. In this case, we said we need at least 15 cases. MapMasq will begin with the smallest census geometry in the area and merge them until a minimum of 15 occurrences are achieved. Now let's take a look at one that's a little more intriguing, which is the denominator rule. The denominator rule states that you must have at least a certain number of the underlying demographic population. This information is pulled dynamically from the census. Please note that no data ever leaves your local machine. The only information sent to the census is the extent of the data and the parameters you are looking for. All data and processing is done locally to ensure the PHI stays protected. In this particular example, the data is only looking at adult males, and the criteria used to establish the denominator reflects that. You'll see males 18 and or older, and we decided in this case we wanted a denominator of at least 15,000 males in the underlying population that meets that criteria. This is the real power of tying your data to census boundaries. In addition to actually going through this process, we save the actual underlying population. So in this case, that first polygon has just over 17,000 males 18 years and older. From this, you can derive percentages and rates and other information that might be relevant to what you're studying without having to actually pull the census data and do that yourself. So now let's look at rounding and truncating coordinates. It is exactly what it sounds like. We simply round or truncate the coordinate of the data point and reset it. The value of this over the simpler bin analysis is that the point level data is retained and not just a count of points. Essentially, the system stacks the points so that there's less loss of information. You can tell this by creating a heat map of the process results. However, for some end users, this format is less helpful than a nice visual grid that the bin analysis creates. Now let's look at the most sophisticated statistical method that we currently employ, which is called K-mean neighbor. It's also been called the donut method because of how it works. You can read more about that at MapMasq.com in the resources section. What K-mean neighbor does simply is it considers the distance to the points around it to determine how far it must be moved to achieve de-identification. The K value is the number of points you want to consider. Because of the properties of a gamma distribution, 5 is a common value you will find in published articles on the use of this method in health research. MapMasq takes this one step farther by allowing you to scale the results to be more conservative by specifying a larger final K-score average. In the example on the screen, we said we wanted the average to at least be between 10 and 12 on a final K-score. In the case on the screen, less than 1% of the points achieved a 0 K-score, meaning this data set has a minimal risk of re-identification. However, if your data set has clustering, achieving no points of 0 K-score is next to impossible. But keep in mind, HIPAA does allow for some risk. It does not have to be 0. As you can see, the final result is representative of the original data, but not a single point is on the original location, and 99% of those points crossed over at least one other point. The data set on the right, which is the process data set, we call that a representative data set that has been de-identified. This means you can actually share this data and process this data depending on the sensitivity and the need for the data. Let's do a quick demo on how this is done in MapMasq. MapMasq is an add-on to the ArcGIS Pro platform. Once installed, you'll be able to simply click the MapMasq button and you will open the MapMasq toolbar. Keep in mind that for some first-time users of census data, there will be some configuring of the Census API, which can be found in the help documentation. In this case, we're seeing a map of toddler hospitalizations. These are the home addresses of where these specific toddlers live. We want to share this information, say, with healthcare providers or other interested entities, but we probably won't be sharing it with the public. So we decide that we can go ahead and use the K-mean neighbor method because giving them more detailed data may be helpful without giving them the actual information. So in this case, we'll just simply select the data. We'll select all the points. And in this case, we're going to select K-mean angular neighbor. In this case, we're using K-mean angular neighbor to try to preserve some of the directionality. Details on the differences between the two can be found in our resources section. In this case, we're going to go ahead and use a K value of 5. And we're going to specify, though, that we want it to be a little more conservative and use a minimum case final average of 6 through 8 and give the tool a range to go find that distribution. We're going to go ahead and process those results. In this case, it's going through every single point and trying to determine what value it needs to move each point and randomly select that. As you can see, all the points distorted, and none of them are on their original locations. In this case, we have about 2.8% of our points did not cross over another point. That does not necessarily mean it's not been anonymized or de-identified, but they are points maybe you want to consider for further analysis. In this case, we're going to say that this is sufficient. This will work for what we want to do. We go ahead and decide to export this information. Now, for the sake of time, I went ahead and exported this ahead of time, and the data will be slightly different. Since a new random seed is chosen for every data set process will be slightly different. In this case, we decide this will work for our particular method and what we want to do. And we want to go ahead and share this with providers in that area. So simply in ArcGIS Pro, if you've configured ArcGIS Online or ArcGIS Portal, you can come in here and hit Share as a web layer and Publish Web Layer. The Share as a Web Layer dialog will pop up. It'll pre-populate some of this information, but what you want to do is make sure who you're sharing it with. We decided we didn't want to share this information with the public, so in this case, we're just going to share it with healthcare providers and researchers. Once we select that, we'll fill out the other respective information, hit Analyze and Publish, and I'll show you a demo of what this looks like on the web after we've completed the demo in MapMasq. Now that we've walked through a simple example using toddler hospitalizations, let's use something that's a little bit broader and covers more ground. So now we're going to look at underage vaping in the state of Texas. These are known incidences of underage vaping. And we want to analyze, are there hotspots? Are there specific items that we need to look at? What would be better for maybe public safety or the general public to look at and know about this information? Obviously, we don't want to release the specific points involved. So we look at it and intuitively we think, well, Dallas has a lot, Houston has a lot, Austin, you see those clusters, but is that really the case? So with MapMasq, you can now kill two birds with one stone. You can de-identify the data by aggregating it, but also analyzing it quickly with some census data. In this case, we're going to say we want at least an underlying population of 20,000 people under the age of 18 to mask this data. So we'll pick our input data, we'll select all of our points, and we're going to pick the denominator rule. And in this case, we're going to pick age group, and the category will be 18 years and under. And the denominator rule will use 20,000. Now, this takes some time to process over the size of the state of Texas, so I'm not going to process this in real time, but if you were to do it, it would reach out to the census data, grab its necessary information, and then process all the information locally. When you're done, though, you end up with this result here. Now, I went ahead and decided to color code it based on 10,000 because people tend to understand that information. However, if you were to open up the data set, you would see that the denominator was actually not 10,000. We just normalized by 10,000 to color code it. One of the interesting things you see out of this data then is you notice Dallas and Houston don't necessarily have as big a problem as some rural areas, and then in this case, Austin. So this gives you some insight while also masking your data. Now, let's say we want to share this information with public safety. You've created them in their group already. We'll simply come up here and open up the web layer. And then we'll come in here and fill out the necessary information. But in this case, instead of sharing with health providers, we're going to share with public safety. This gives you the control over who sees this data. So even though it's been de-identified and masked, you can still have some control over who has access to this information. Now let's look at our next example. In this one, public safety is asking us for some specific opioid information that we have, but we want to de-identify it because they also want to share it pretty broadly with maybe sheriff's departments and local law enforcement. And you're not quite sure who's going to get access to this data, so you want to make sure you de-identify it first. You decided to use a couple different ways. Looking at it, you realize that maybe it might be better for them to be able to have gridded data or hexagon data. And so you went ahead and used the bin analysis tool to come in here, pick the data set, and then you pick the shape you want and the size you want. What I'm going to show you is this data set in various square miles. So these are 100 square mile grids. This is the data set in 50 square mile grids. And this is the data set in 10 square mile grids. Depending on who's using this data, how de-identified it needs to be, you can adjust that size depending on the extent of your data and the sensitivity. So you decide you're going to share this information with them because this information might be helpful, and depending on what size of an agency they are, this various sizes may be helpful. But you also decide to go ahead and look at some rates. Now this is adult male data, so using the denominator tool again, You came in here, picked the data, you selected all the points. We can go ahead and turn those back on. Pick the denominator rule, but in this case, you picked age group and sex, and you picked males 18 years and older, and used a denominator. I believe I used 15,000 when I ran this. For the sake of time, once again, we'll go ahead and just look at the final results. And because you have that underlying census data, you're able to look at the rates of adult males 18 and older who are opioid users of some kind. So this information may be useful to law enforcement. It may be useful to healthcare providers. It could be useful to emergency and responders. There's all sorts of people that this information might be valuable to. Once again, you would share it the same way. You would just pick the groups you want to share it with, and then you would share. Now, the final demonstration I want to show you is what you might release to the public. For the public, you may not want to give them layer level information where they could drill down into the data a little bit. You may just want to give them a generic map that's labeled. In this case, we'll say this is for public release, and you've made the map using that same opioid data set, but put a background map in, color-coded it a certain way. But in this case, you're going to publish it as a web map and not a web layer. This way, they have less access to the individual layer data. They only have the ability to look at the high-level data and what you decide you want them to see. This will allow the public maybe not to be confused over the information or other considerations you might want to make. Now that we've seen how this actually looks in MapMasq, let's take a look at what this will look in ArcGIS Online or ArcGIS Portal. What you see here is a landing page to ArcGIS Online. Notice at this point, nobody has signed in. I'm just going to come in here and type in opioid, and you'll notice there's a few different maps here. So this is the one where we have some mass data that we just shared as a web map. I'm going to open it up. Let's just go ahead and open it up in a map viewer. And the general public would be able to access this information. You can share it through a more easier to use page or other information, but it is open to the public. Now let's contrast this with another browser where I've actually logged in. So as you can see in this browser, I've already logged in as the public safety user. So this would be somebody with a public safety user group login and password. I've already gone over here and opened up the groups tab to see what data I have access to. And in this, we have the data that I shared. You see the different square mile data, the percentages of adult males that have been shared already with this group, and they have access to it. And notice they have different options. They're actually able to drill down into this data, not just in a map viewer, but have other options, and also able to look at various metadata and other information regarding this data. So they get a more detailed view because of how we shared it with them. Now let's take a look at our provider user. In this case here, you've given access to one of your regional medical providers who maybe either supplies you data or shares data, or you share data back out to them. We've logged in as that provider, and we're just going to go over here to our groups, and you will see in this case it has access to the data that we've provided earlier. So we'll pull it up, and here you'll see that toddler hospitalizations in Austin. That's data that's been shared with them, and they'll have access to that just like the public safety had access to their data. So this allows you to segregate who you share data with. Even though it's been masked, you can further define who has access to what data just by simple logins and access. Now that we've looked at how this actually works, let's just reiterate the process real quick. Using MapMasq, holders of PHI of relevant public health data can de-identify that data locally in a HIPAA-compliant environment using MapMasq. Once it's been de-identified, it can be uploaded to ArcGIS Online, ArcGIS Portal, or other sharing environment that is not HIPAA-compliant. Using permission schemas, you could actually grant data to various levels of users, whether that's for analytics, research, public safety, or the general public. Some of the common questions we get regarding this: can MapMasq be supported in a server or cloud environment? Yes, we do have an API that can be programmed directly into a HIPAA-compliant environment. Contact us for more details on that. Is ArcGIS Pro and ArcGIS Online required? Yes, at this time, unless you're using the programmable API, ArcGIS Pro is required. ArcGIS Online and ArcGIS Portal are not. It is just used to share and analyze the data further across your users. You can use another platform. Can a provider use MapMasq and upload data? Absolutely. If they purchase a commercial license of MapMasq, they can master data and send it to you, or even use it for their own internal use if they have a need within their entity to mask data, study it, and share it. MapMasq licensing for state government is done in a special arrangement. We actually will give an enterprise license to the state government with one single purchase. Every single state, county, city, and those sub-entities of police, fire, as long as they are a government within the state that is a sub-entity of the state in some kind, we will allow them access to MapMasq under that one enterprise license. The state would be responsible for distribution of those codes though, so you can have as many of those as you need for those entities, but you're responsible for distributing them. It does not provide licenses for any federal, university, education, commercial, other users in your state, except in cases of declared emergency or natural disasters, and we can talk about that if the situation arises. You will need ArcGIS Professional or ArcGIS Pro before using MapMasq, except for the API version if that's something you're interested in. That's all we have for today. Thank you for watching the video. If you have any questions at all, please go to mapmasq.com or email us at mapmasq@gisinc.com, and we will get with you and talk about the details of how much it would cost for your state, other questions you might have, or other functionality that might be available. Thank you.